Hi, everybody. Thanks for attending. Hopefully, I'm coming through okay. My name is Eric Finver. I head up the Mammoth Squad, and we're excited to present this powerful presentation. Myself, representing Mammoth, and my colleague Kevin Parker, who represents AppVance. And we're going to show you a powerful way of approaching tests and really leveraging the power of AI and machine learning in the test execution rigor process area, and give you a sense of how testing is really being achieved today. It's not something that's a future state anymore. It's really being achieved today, and being done in a powerful way. So let me jump into the presentation, and then I'll make an introduction of our company, Mammoth, and also have Kevin introduce the AppVance team and the AIQ platform. So the partnership between Mammoth and AppVance is powerful. We're not only a systems integrator for their platform, but we're also a client. And so we can vouch for the application that Kevin's going to present today. It's extremely powerful, and it's provided tremendous value to our customers. As an organization, AppVance is devoted to QA and QA excellence. We have our own delivery capabilities in QA. We have our own test methodologies, and we deliver a test center of excellence to our customer base with our capabilities. We, as an organization, we create, we execute, we maintain tens of thousands of scripts every month for our customer base, and not in short order. We have the ability to do that because of our partnership with AppVance. Our organization has experienced 30% growth year over year since our inception. And after really becoming a customer or client of the AppVance organization, we have experienced zero defect leakage over the last 3 years. Okay, so try to wrap your minds around that while I jump into some of the details of how that's happened. The ultimate goal of testing, as software testing, as you guys know, or should know, is ensuring software quality. Now, when I put that and pose that question, even to team members on the Mammoth side, I get the response that, well, the purpose of testing is to find bugs. Yes, of course. But of course, at the end of the day, that is the means to the end. The end is software quality and delivering a quality product that users can leverage, that users can experience in a way that allows them to get their jobs done, do things more efficiently, be able to do more things than they were able to do before. That is the purpose of software. So how do we get to ensuring software quality? Well, there are a couple of metrics that people measure. And the two that I want to highlight is test coverage and defect leakage, because I think that they are critical KPIs when it comes to helping us to understand where the industry is today and where we're headed, or where we are today when we leverage the AppVance IQ platform. In today's world, test coverage, which is what we mostly go by in terms of what are we achieving, is defined here, the percent of application covered by tests that have been born out of our requirements. So essentially, a human is eliciting the requirement of what we need to test in any given sprint cycle. And then based on that, we are creating tests. Hopefully, we're creating automation. So that makes us more efficient. The reality is that when we look at what we're covering in that application, we're actually only getting to, or at least the industry says, that we're only getting to about 20 to 40% of the application itself in any given execution. That is what I would consider to be probably that's a gracious number, actually. More conservative numbers would probably put it at like 10% or less of the application that we're covering, because the simple fact of complexity of applications, and of course the shrinking timelines to delivery has caused the testing teams to struggle to cover the entire application. So we're getting the amount of covering of application is getting smaller and smaller as we go forward. Okay, so think of it in those terms when we talk about test coverage. A lot of us say, hey, we get to all our tests, it's 100% test coverage. It's a very small percentage of the application, in fact. Okay, and then the second KPI I want to cover is defect leakage. So what really matters to product owners and to people who have their jobs on the line when it comes to software is, what does it look like in terms of quality? What are the bugs that are slipping through our efforts and our cycles to make sure that we're releasing a quality product? And we identify that through defect leakage. And that could be looked at through the process itself. But ultimately, it's what does it look like post-production? And when you release, post-release, it's referring to the percentage or the number of defects that are leaking into, production once we release the software. Okay, the industry average, staggering 10 to 15% is the percentage of all defects that get uncovered. It's happening because we're not covering the application. We're not getting to the things that we don't have time to get to. We're not getting to the things we didn't know we needed to get to. Okay. And as the complexity of development and the development cycle and the applications themselves become greater and greater, the chances of defect leakage percentage and numbers to go up gets greater and greater. Okay. So how are we going to stop this thing? Right? How are we going to stem the tide of defect leakage into a release? We need to cover the application in a greater way. We got to try to get to as close to 100% as possible. Okay. What if we could do that? What if we could get to 100% application coverage? Okay. What if we were to uncover and define and test for all the possible interactions, user interactions and executions and flows and edge cases that exist in our application? What if we could test not only for the things that we know that are clear and present, but the things that we know that we may have missed because of time constraints, or the things we forgot because we just have too much on our plate? Or even more profound, the things we didn't know existed, things that are inherent in the application because it's the way the application was created. They exist. The problems exist in the application, and we didn't know to check for it, but it's there. Okay. In other words, what if we could test all the flows and the actions that exist in our applications, everything we didn't have time to test or simply didn't know existed? Okay. And this is the purpose of what we're going to showcase to you here very, very shortly. So by moving from just a sliver or a slice of the application, slice of the pie, so to speak, to test coverage, from test coverage to application coverage, all right, and getting 100% or near 100% of all those things we need to test, this is how we would drive through quality in our applications, in our software. Okay, and our argument to the audience is that by using AI, sophisticated AI algorithms, and Kevin's going to share on this momentarily, we can do all the above by enlisting the help of machines to help us achieve this at speeds and scales that no human can do, and no group and no team of humans can do. But with leveraging the power of AI, we can do that. By training these algorithms, we can test or validate for every page, every state, all actions and flows, all the calls and responses, their timings, etc. Every execution that exists in the application, AI can test for if we've set it up and trained it to do so. Okay. So by training those bots to execute on our behalf, we'll increase our performance by a minimum 10x, which is, based on operational research. You can't even really put a number on it, because when machines are executing and creating tests autonomously on our behalf, you can't even put a number of scale in terms of the proficiency that it's executing on our behalf. But we'll use it for argument's sake, that number. Each one of us will gain a scale of 10x, will massively increase the application coverage, but thereby uncovering all the defects that may be residing in our application, and drive to zero defect leakage. Zero. Okay. And what does that mean? That means that your product owners will be able to sleep at night soundly. They'll have the comfort that we are reaching in to the application's nooks and crannies, finding every single bug that may lurk there. Thank you, Kevin. Wonderful presentation, and drilling through the finer points of the platform. And suffice it to say, there's much more in the engine than just the things that we've highlighted. But these are some of the key ones that really allow the audience to know how ML and AI is supporting testing and doing it so today. It's not 5 years from now. It's now. And what I'm going to do is, before we open it up to questions, I just want to share my screen and give the audience a sense of the power of, wait a second, I gotta share it first. Give the audience the sense of the power of what this platform does in the real world. So let me share this. No, we're not supposed to be sharing that. We're supposed to be sharing this. Okay. Let me put this into presentation mode. Are we good there, Kevin?
You're good.
Wonderful. So a quick case study, and then we'll be able to open it up for questions. We just recently did this for a client. They're a payment processor, third-party payment processor, and they're doing electronic payments. And the client came to us and basically said, look, with the number of testers that we have today, we're struggling. And our ratio is about, I think it was one for every 2 developers, there were 1 tester on just about, and which is abysmally bad. When the going best practice model is, if you're really good in your rigor from a test standpoint, for every 4 developers, you have a single tester. They had for every 2 developers, single tester. So they were highly inefficient. And not only that, they were releasing applications. First off, they were having a hard time releasing their applications, and because of the time delays. And then secondly, when they would release applications, they were releasing clear and present bugs into production. And it was really destroying their credibility. And they have some extremely tight SLAs that they have to manage to. And so they came to us, and we basically, we looked at it and we said, no problem, we can do this. And we started to build. As soon as we onboarded, we started creating scripts on day 1. Okay. We were running AI on day 3. And so what was happening was we were moving at an accelerated pace. Within 30 days, the customer was in production with 1,000 test cases written by ourselves, 711 scripts created, automation scripts created by engineers. This is the low code module, that a piece of the platform that Kevin was presenting. And we were able to identify 177 bugs within 30 days. Okay. They were able to go into production in their release cycle on time with 0 defects. Okay. So this is a clear area of opportunity where your organization can adopt AI into a critical process of your DevOps, to utilize it to ensure that at the end of the sprint cycle, when you are ready to release, you are going to release a quality product that your teams can be proud of, that your product engineers and chief product officer can be proud of, and can rest assured and sleep well at night that the testing team has ensured that the product is of a high caliber and of quality, and that the chief product officer is not going to get a call in the middle of the night that they had a major failure in the application. So this is a referral or reference, clear and present use case that's documented, referenceable, et cetera, and has been done very recently here. So it's very fresh and very powerful.